Hello, welcome to In 5 Minutes. The next type is the common base NPN transistor. How to identify the type of the transistor? As I have told you, arrow is always from P to N. So this is P, this is N. So remaining terminal is N. You have NPN type of transistor. How to identify that it is common base? For that, see the input. Input is given to the emitter. This Vs is applied to the emitter terminal. This is your emitter terminal. Output we are taking from the collector, so we are left with the base. So it is common base NPN type of transistor. Now you can have two type of problems. You can say on this, one is the derivation and other is the normal analytical problem. So derivation can have this type: derive the expression for voltage gain, input impedance, output impedance for common base NPN type of transistor. Or the question can be, all the values will be given, all the component values will be given in the question. The value of beta, Va, everything is given, and the question is to determine the small signal transistor parameters, that is R pi, Gm and Ro. After that you need to find the voltage gain, Av, and then the input and output impedance. So you can have two type of problems based on this. So what we'll do, we will do the derivation as well as we'll do the problem on common base NPN type of transistor. Now to start with, what we are doing, we are drawing the circuit under DC operating conditions. For that, what we'll do, we remove the AC sources and open circuit the capacitor. Now what all capacitors will be open circuited? This capacitor will be open circuited, this will open circuit, so this part will be removed from the circuit. Again this will be open circuited, so this part will remove from the circuit. Similarly over here, this part will be removed, this part will be removed, and this part will be removed. So you are left with, the circuit will look like, you will have only REV, only this much part. What we are left with, we are left with the part which is shown in blue color. Similarly over here, we are left with this much part which is shown in blue color. So how you will draw the circuit? The circuit will look like this. So once you have found, so what we can call this? We can call this circuit under DC operating condition. So what we need to find? We need to find IB. So what we'll do, we'll apply KVL to emitter base. Now how to identify the direction of currents? Arrow is always from P to N, so that means this is emitter current, it is flowing outward. That means IB and IC should flow inwards, because in order to satisfy the equation, IE is IB plus IC. So in order to satisfy this equation, IB and IC need to flow inward. So this is how you will get the direction. What is the direction of VEB? This is plus or minus. The other terminal, this will be negative, this terminal will be positive because of the direction of the current. And this will be VEB. It will be negative upwards, positive below, because we are forward biasing the JBE diode, that is JBE junction. So for that, VEB will be the case. So when you apply KVL in this, what will be the equation? You will have IBQ equals to total voltages in the numerator. You have VEE, negative positive. We are going in this direction, living with positive sign. So VEE, we are living with negative sign for VEB. So minus VEB on divided by RB. Current flowing through RB is IB, so I am writing as RB, but current flowing through RE is IE, so 1 plus beta times, so you can find IBQ. Now for the problem, you can find IBQ as VEE is 10 minus VEB on is 0.7, all divided by RB is given as 100 kilo ohms, and beta is given as, how much is the value of beta? Beta is given as 100 in the question, so 101 into Re is given as 10. So this will give you the value of IBQ as 8.37 microampere. Once you know IBQ, you can find ICQ as beta times IBQ, right? Similarly, from the value of ICQ, you can find R pi, which is beta Vt upon ICQ, and GM. Equation for GM is ICQ upon Vt, and Ro, which is Va upon ICQ. This is what we need to do for derivation. For problem, we need to find ICQ. So ICQ will be beta times IBQ. So this will give you the value of IC. So when you multiply it with 100, you can find the value of ICQ. You can find R pi as beta Vt upon ICQ, or it can be written as Vt upon IBQ. You will get one and the same value. So Vt upon IBQ will be 26 millivolts upon 8.37 microampere. So that will give you 3.1 kilo ohms. We have got the value of R pi for the problem. Similarly, we can find GM, which is ICQ. I can write beta IBQ upon VT. So this will give me GM as 32.19 milliampere per volt. So I've got GM. Since VA is given as infinity, I will get RO as infinite. So I've got the values of parameters which are required in EC. So this we have completed the DC operation. Now we go for the AC operating conditions.